Hello students, welcome to Crashing Online Classes. We'll start the revision classes. In this revision class, first I'll discuss your question paper pattern. Your midterm exam question paper pattern will be same as that of final exam question paper pattern. So in the Roman number 1, there will be MCQ question, multiple choice question. 8 multiple choice questions will be there, and for each 1 mark, 8 marks. And while writing multiple choice question, you have to write the answer along with the alphabets. It is given in the instruction itself. For example, you are starting Roman number 1 and the first question, first multiple choice question. There will be 4 options A, B, C, D. Suppose if the correct option is B, B is the correct answer, then you have to write first one B and you have to write the answer. Whatever answer it is given, you have to write. So in the same pattern you have to write in the exam also, even in the final exam. Roman number, question number, alphabet and answer. Not only writing only answer or not only writing only alphabets. Both you have to write. Then Roman number 2 will be 1 mark question. You will be having 8 1 mark question and 8 into 1, 8 marks. Roman number 3 will be 2 marks question. You will have 8 2 mark questions. 8 into 2, 16 marks. Roman number 4 will be 3 marks questions. You will have 9 questions of 3 marks. So 9 into 3, 27. Roman number 5 will be 4 marks question. You will have 4 questions of 4 marks. 4 into 4, 16. And Roman number 6 will be 5 marks question. Only 1 question will be there. 5 marks, 1 question. 5 into 1, it will be 5. So altogether 80 marks. So this 5 mark question you may get from the physics part or chemistry part or biology part. And here in the 4 mark question, 1 physics question, 1 chemistry question and 1 biology question and 1 extra. Sometime you will get 2 biology questions, or sometime you will get 2 chemistry questions in 4 mark, or sometime you will get 2 physics part questions for the 4 mark questions. So usually out of 80 marks, your biology marks will be, it may be 28 or sometime 29 or sometime 30. 28, 29 or 30 depending on the question paper. Remaining is physics and chemistry part. Now I discuss the diagrams which are there for you to study for the exam purpose. So first lesson is deleted from your textbook. Second lesson, that is acid, base and salt. In that lesson, in page number 19, page number 19, page number 19, figure 2.1. Page number 19, figure 2.1, this diagram, that is the reaction of zinc granules with dilute sulfuric acid and testing hydrogen gas burning. This page number 19, figure 2.1, this diagram can be asked sometime for 3 marks, sometime it can be asked for 2 marks. So a very important diagram. Next, from the same lesson, in page number 22, page number 22, page number 22, page number 22, that is the figure 2.3, figure 2.3, this diagram, page number 22, figure 2.3, this diagram, that is the acid solution in water conduct electricity. This diagram, it will be asked for 2 marks. Next, same lesson, metals and non-metals, that is the lesson number 3 from the chapter number 3, metals and non-metals. In that, page number 43, page number 43, figure 3.3, page number 43, figure 3.3. Page number 43, figure 3.3, this diagram. It can be asked for 3 marks or it can be asked for 2 marks. The name of the diagram is action of steam on a metal. Very, very important diagram. 3 marks it can be asked for or for 2 marks. So action of steam on metal. It is there to draw. Next, in the same lesson, metals and non-metals. In page number 48, page number 48, figure 3.8. Figure 3.8, not this one. Figure 3.8, this diagram. 3.8, that is the testing the conductivity of a salt solution. This diagram. It will be asked for 2 marks. 2 marks diagram. Testing the conductivity of a salt solution. Next, in the same lesson, metals and non-metals, in page number 53. Page number 53, that is the electrolytic refining of copper. Figure 3.12, electrolytic refining of copper, very important diagram. This diagram can be asked for 2 mark or 3 mark. If you get one question along with the diagram, it will be asked for 3 mark, or suppose if it is asked only diagram, it will be asked for 2 marks. So, electrolytic refining of copper, you have to remember by drawing the diagram, electrolytic refining of copper. One cell is connected there, a cell is given, this is a cell, that is one positive terminal and one more is negative terminal. So, this cell is connected to a key, cell is connected to a key, and in the beaker you are taking acidified copper sulfate solution. This diagram is given for the assignment, but most of you did not draw this solution here. It is given in your textbook, a light blue color, it is shaded in the textbook, light blue color, that is acidified copper sulfate solution that we have to take in the beaker. That should be mentioned in the diagram. The solution you have to draw, that is the acidified copper sulfate solution. Then you are taking 2 electrodes. 2 electrodes you are drawing, and while drawing the electrodes, here the plus should be connected to this. This is plus, that is anode. The plus, minus, plus, positive terminal should be connected to the anode, and negative terminal, this minus should be connected to the cathode. This side is cathode. You should not interchange the connection. Plus should be connected to anode, plus, minus should be connected to the cathode. If you change the connection, suppose if you draw like this, if you draw this minus, this is plus, if you draw in this way and if you write this is anode and this is cathode, the whole diagram will be wrong because current is not flowing through the solution in this type of connection. This is wrong connection. Minus, this is anode, plus, minus, plus, we should not connect this diagram. This type of connection, it is wrong. So, this is the usual mistake that most of the students done so far. Minus, plus, we should not connect, the diagram will be wrong. You have to connect here, positive, plus, minus. Positive should be connected to the anode, that is plus. Plus should be connected to the anode. Plus means long line, small line is minus. Minus should be connected to the cathode. And in the diagram it is given an arrow mark like this. That is Cu plus 2 or Cu2 plus. Its direction should be towards cathode. That is moving towards cathode like this. Arrow mark should be like this, in this way. It is moving towards cathode. The copper ions are moving towards the cathode. This you have to remember while drawing the diagram. One thing, you should not change the connection here, and one more thing, this direction. If you write wrong direction, marks will be deducted. The movement of the ions, it should be towards the cathode, this direction. That you have to remember while drawing this diagram. Then we will move to the next lesson. Next, electricity lesson in the physics part. In page number 94. Page number 94. Page number 94. Figure 2.1. This diagram will be asked for 2 marks. It is there in your list of diagrams for the exam. Figure 12.1. Figure 12.1, page number 94. The heading is schematic diagram of electric circuit consisting of cell, bulb, ammeter and plug Page number 94, figure 12.1, simple circuit diagram. This is there for the exam. So here you have to remember the direction of the current. In which direction current is flowing, that you have to remember. Next, in the same lesson, electricity lesson, in the page number 97, table 12.1, that you have written for your assignment, page number 97, that is the symbol of commonly used component in the electric circuits. Table 12.1, this full table you have to study for the exam purpose. This question can be asked for 1 mark or it can be asked for 2 marks. Two symbols they may ask to write, or one for 1 mark can be asked. These symbols you should know, you have to remember. And in the same lesson, electricity lesson, in page number 98, page number 98, this page number 98, there in the box, blue color box, at the top one diagram is there, that is figure 12.2, figure 12.2, electric circuit for studying Ohm's law, electric circuit for studying Ohm's law. This diagram is there for your exam, you have to study. Electric circuit for studying Ohm's law, figure 12.2 in the page number 98, this diagram. So here don't worry about the parts. Here A means emitter, K means plug key, V in the sense voltmeter. So this diagram you have to study for the examination, for your exam purpose. And here XY is given. There is a part XY. This side is X, this side is Y, and this is given R. R means that resistance. XY, that XY is nichrome wire. Nichrome wire. This is a nichrome wire, XY. So this is there for your exam 2 marks question. Draw the diagram which is used to study Ohm's law. Page number 98, figure 12.2, this diagram. Next, in the same lesson, page number 104, figure 12.6. Page number 104, figure 12.6, that the resistors in a series, 3 resistors in the series, and figure 12.7, 3 resistors in the parallel. How to connect parallel resistance, series resistance. So series connection, parallel connection. This diagram can be asked for 2 marks or for 3 marks. These 2 diagrams are there for your exam to draw. Next, we'll move to the next lesson, that is the magnetic effect of electricity. In that lesson, page number 121. Page number 121, magnetic effect of electricity. Page number 121, in that figure 13.6, in figure 13.6, diagram A, first diagram, this diagram, not this one, not the B diagram. The first diagram, diagram A, figure 13.6, page number 121, figure 13.6, in that first diagram A, that is the pattern of concentric circles indicating the lines of magnetic field. The magnetic field around a straight conductor, the pattern of the magnetic field around a straight conductor. This diagram, first diagram, you have to study for the exam. Next, in the same lesson, in page number same lesson, page number 126. Page number 126, that is the electric motor, the diagram of electric motor. This is very important diagram, can be asked for 2 marks or 3 marks. Electric motor, figure 13.15, page number 126, a simple electric motor. And also one more diagram in page number 130, page number, figure 13.19, that is the simple electric generator. This diagram, electric generator, very important diagram, 2 marks or 3 marks. So these are the diagrams which are there for your exam, that is for the midterm exam. The diagrams which are there, you will get the questions related to these diagrams that you have to study for the midterm exam. Now I will discuss 2019 midterm exam question paper, last year's midterm exam question paper. So in this I will discuss only physics and chemistry part, and the questions which are the portion which are there for this year, the questions related to those portions. The first one, multiple choice question, Roman number 1. The first question given like this: the device which works on the principle of Joule's heating effect. The device which works on the principle of Joule's heating effect. So what is heating effect? Electrical energy is converted into heat energy. So first one is STD, second one is iron box, third option mobile, and the fourth option is fan. So in which device we are producing more heat? Actually here TV, mobile and fan, if we use them continuously, they produce heat. But where, in which device we need heat? Our intention is produce heat. Using electrical energy, we get more heat energy. So our work is based on that heat energy. So which device that? Iron box. Option B, answer B, that is iron box, which works on Joule's heating effect. In the notes also given, also it is there in the textbook. The devices which works on Joule's heating effect. Many devices, around 8 to 9 devices are given which works on Joule's heating effect. Now go to the second question. The following formula does not represent Ohm's law. Which formula does not represent Ohm's law? So what is our Ohm's law formula? Ohm's law formula is V is equal to I into R. This is the actual formula. V is equal to IR. So V is equal to IR, Ohm's law formula. Now I keep R this side and I bring I this side. When you keep R in one side, when you bring I to other side, it will be V divided by I. So R is equal to V by I. R equal to V by I. This is also Ohm's law formula. Just by interchanging some of the devices or some of the letters, you will get R formula. Resistance is equal to V divided by I. Now from V is equal to IR, from the same formula I write V is equal to, instead of I, what is I here? I in the sense current. In the beginning of the lesson, electricity lesson, in the beginning we defined current. So what is current? Current is rate of flow of charges, the flowing charges per unit time. The equation used to calculate current, I is equal to Q divided by T. So if you remember, just recall the beginning of the lesson, the formula of current, I we have written I is equal to Q divided by T, and this R as it is right. So QR by T, I can write V is equal to QR by T. So this is also Ohm's law formula. Just interchanging, just substituting the equation for I, we get QR by T. Now go to the last formula. V is equal to I divided by R. Actually V is equal to I into R is Ohm's law. Not V is equal to I divided by R. So this is the answer. This is the formula which does not represent Ohm's law. This is not Ohm's law formula. So answer is V is equal to I divided by R. Now go to the next question. The device used to produce electric current. Which device is used to generate electric current? See the last option, motor. Motor is a device which converts electrical energy into mechanical energy. To get the mechanical work, we are using motor, not to produce electricity. Go to the next option, ammeter. So what is the function of ammeter? Ammeter is a device which is used to measure the current, not to produce the current. To measure the current, we are using ammeter. Go to the option, generator. So what is generator? Generator, you have studied definition. It is a device which converts mechanical energy into electrical energy. To produce electricity, we are using generator. The device which is used for producing electric current is generator. Is a device which is used to produce electric current. When you come this galvanometer also we are using in the circuit, but the purpose of using galvanometer to identify whether current is flowing in the circuit or not, to identify or to just to test to flow the current, we are using galvanometer to identify whether the current flows in the circuit. To identify the current, we are using galvanometer, not to measure the current or to produce the current. To identify the current, galvanometer is used to, ammeter is used to measure the current. To produce the current, we are using generator. Go to the next question. Tooth decay starts when the pH of the mouth is lower than, when the pH is less than, it is given in the notebook also. If the pH is less than 5.5, tooth decay starts. Go to the next question. Next multiple choice question. Iron nail is dipped in the copper sulfate. Iron is dipped in the copper sulfate solution. The blue color of the solution fades. Because, so the reaction between the iron and the reaction between the copper sulfate. This is the metallic salt, the solution of metal salt, copper sulfate solution. Iron. When you compare iron and the copper is less reactive, iron is more reactive. So, when a more reactive metal react with the salt solution of less reactive metal, then the more reactive metal displaces less reactive metal. Iron can displace copper from copper sulfate solution. Displacement reaction, metals and non-metals. Chemical properties of metals and non-metals. In that we have studied displacement reaction. What is displacement reaction? The reaction in which more reactive metal displaces less reactive metal from its compound, from its salt solution. So iron can displace copper because copper is less reactive, iron is more reactive. So we'll see the option. First one, copper sulfate is acidic. No, this is the wrong option. Second one, iron displaces from its salt, not its salt. From iron is not displacing, not from its salt. From the less reactive metals salt. Go to the third option, copper displaces because copper is low reactive than iron. When you compare copper and iron, copper is less reactive, iron is more reactive, so copper gets displaced. Copper gets displaced by the iron. Last one, iron displaces because iron is less reactive. So this is also wrong. Iron is not less reactive than copper. Copper is less reactive than iron, so copper gets displaced. Iron takes the position of copper. So correct option is C. That is, copper displaces because copper is low reactive than iron. That is displacement reaction. We'll move to the one more questions now. So question number is given continuously. You have to write continuous number in your answer sheet also. Next question. List two properties of magnetic field lines. I have given 4 properties of magnetic field lines in your notebook. Magnetic field lines do not cross each other. Outside the magnet, they travel from north to south pole. Inside the magnet, south to north pole. The magnetic field strength is maximum near the polar region or near the poles. Then magnetic field lines have both magnitude and direction. So these are the properties of magnetic field lines. You have to write any two properties. For two properties, for each property half mark, two properties you will get 1 mark. Next question, what would be the changes? What would be the changes do you observe in the current, in the electric current if you increase the length? If you increase the length of the wire having constant resistance, you are increasing length of the wire. The question is asked, what is the change you observe in the current? What happens to the current? Whether current increases or whether current decreases if you increase the length. We have studied the factors affecting resistance: length, area of cross section, nature of the material and temperature. So, as you increase length, when the length increases, resistance also increases. Resistance is directly proportional to length. Even though they say there constant resistance, R is proportional to length. As the length increases, resistance also increases. So here given length is increasing, at the same time resistance is increasing. Resistance increases. What is resistance? Resistance is the opposition to the flow of current. It is the opposition to the flow of charges. As the resistance increases, whether current is flowing more freely or it is difficult to flow the electric current, electric charges, it is difficult to flow the charges if the resistance is more. So, as resistance increases, electric current, the flow of the electric current decreases as the resistance increases, because it is given length increases, so resistance increases. What about the current? Your question is asked about the current. What happens to the electric current? Electric current would decrease. If you increase the length of the wire, the electric current, the flow of electric current will decreases. The current would decreases. Electric current decreases. Decreases is your answer. Current, flow of current or electric current decreases. Next, if you get the question here, justify. It is asked what would be the what changes do you observe in the current? So changes in the current decreases, electric current decreases. But what is the justification you are giving? As the length increases, resistance increases. So as the resistance increases, flow of current decreases. Therefore, electric current decreases. The current decreases. Go to the next question. Sodium bicarbonate. Sodium bicarbonate means sodium hydrogen carbonate, that is NaHCO3. Sodium bicarbonate, sodium hydrocarbonate or sodium hydrogen carbonate is basic. It is a basic in nature. Justify this statement by giving one reason. How you are saying sodium bicarbonate is basic in nature? So we have done many tests to say the acidic as well as basic nature. In one of the simple test we can take red litmus paper and blue litmus paper test. That is the litmus test. Phenolphthalein test is there. Then methyl orange test is there. So you can use any test. You can say any test. Sodium bicarbonate is basic in nature because when we say basic nature, if you consider the litmus test, if the red litmus paper, if it is converted to blue, red litmus paper converted to blue color, then we say that the solution is basic. Or if red litmus solution changes to blue color, we say that the solution which is given is basic. So you can write here methyl orange test also you can use, or phenolphthalein also you can use. So this is a simple one. Sodium carbonate changes red litmus paper into blue color. Therefore, sodium bicarbonate is basic. Sodium bicarbonate changes red litmus paper into blue color or red litmus solution into blue color. Therefore, sodium bicarbonate is a base or it is basic in nature. Go to the next question. Even though pure gold is 24 carat, pure gold is 24 carat gold, it is lustrous and solid. We cannot use this metal alone to prepare gold ornaments. So why? Why 24 carat gold or pure gold cannot be used to prepare gold ornaments? Why? Because 24 carat gold or pure gold is very soft. Therefore, it cannot be used to prepare gold ornaments. Half mark. Why? Because pure gold or 24 carat gold is very soft. So, it cannot be used to prepare gold ornaments. What would be the other alternative to prepare gold ornaments? Justify what we can do. So, gold should be alloyed or gold should be mixed with the silver or copper. It is alloyed with silver or copper. Gold is alloyed with silver or copper or it is mixed with silver or copper so that it will become hard. It becomes hard, so which can be used to prepare gold ornaments. What is the other alternative? We have to mix this gold with the silver or copper or it is alloyed with silver or copper. Justification which makes it hard, so which can be used to prepare gold ornaments. 24 carat gold cannot be used to prepare gold ornaments because it is very soft. Other alternative, it should be alloyed with silver or copper which make into hard, which can be used to prepare gold ornaments. So in this way you have to write answer, you have to give answers for these questions.